go with question 1. Which of the following alcohols cannot be transformed by this hydroboration process? Okay, so if you look at this compound here, all right, let's look at this compound here. Let me draw it out first. Okay, this is what it looks like. All right, and this is the final product. This is the final product. You put CH3. Let me just draw this side. All right, CHH. Okay, if you did realize, right, they put the H over here and put the OH over here. So it's actually against Markovnikov's rule, because Markovnikov's rule states that the hydrogen will go to the carbon with more H. So typically, the hydrogen should go to this carbon, right? Then the OH should go to the other carbon, because this carbon has two H's, right? This carbon only has one. So this is more like a bit like a anti-Markovnikov's, right? Because you need to know the mechanism. So this is what happens. So just the opposite of Markovnikov's rule. Which of the following alcohols cannot be formed by this hydroboration process? So maybe I'm just going to do two options, A and B, and then for you to take a look. All right. So you start from but1-ene. So but1-ene looks like this. Okay, but1-ene. So this is but1-ene. All right. Okay, and eventually you get butane-2-ol, alright, butane-2-ol, which is CH3, CH2, let me just put here, butane-2-ol means the OH here, and actually the H over here, alright. So you put the H here and the OH over here. So looking at this structure, actually this is like following Markovnikov's rule, alright, following Markovnikov's rule, but this mechanism is like anti-Markovnikov's rule, so it's just opposite, which means A is wrong. Okay, A is wrong because it's incorrect. You cannot form it this way because actually follow Markovnikov's rule. Okay, let's look at B, whether it's feasible. Okay, let's look at option B. We start from 2-methyl-propene. So 2-methyl-propene looks like this. Propene, right? 2-methyl means the CH3 on the second carbon. All right. So what you get 2-methyl-propan-1-ol, 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 which means 1-ol means the OH goes here and the H goes here. So actually, if you look at this one, typically according to Markovnikov's rule, H should go here and OH should go here. But since this mechanism is like anti-Markovnikov's rule, so the OH actually will go here and the H will go here. Alright, so that's what you got, which means this one, B, is actually this 2-methyl-propan-1-ol can be formed from 2-methyl-propene, yeah, via this hydroboration process. Okay, so that's why the answer is A. Alright.